This video will teach you how to find the volume of prisms, cylinders, and spheres. Definition of volume is it is the measure of the amount of space inside a solid figure. For volume, we will be using cubic units. Volume formulas. Prism and cylinder have the same volume formula, capital B times H. Sphere is 4/3 pi r to the third power. Kind of a brief synopsis of where these formulas are coming from. Thinking about taking the area of the base, and it's a full area, and if you were to stack a bunch of these triangles on top of themselves all the way to the top, you'd be left with volume, which is why it's capital B, area of the base, times the height, meaning height of the solid, because we're adding up cross sections until they fill the space. So when we deal with prism, that capital B can be a triangle, can be a rectangle, can be a square, can be any sort of shape. When we would talk about cylinders, very closely to how the surface area was, cylinder is a prism, but with cylindrical bases. So if you were to take the area and stack up the circles on top of each other until the height of the shape, you'd have the volume. Because a cylinder always has a base that's a circle, I'm going to replace that with pi r squared, and it still needs to go the whole shape of the solid. Volume, 4/3 pi r to the third power. And I know that this one looks the weirdest, but if you think again about adding up cross sections, adding up circular, this circle, and then this circle, and then that circle, and all of these circles added up through the whole thing, they're not all the same amount, which is kind of where the 4/3 and the r to the third are coming from. All right, so let's use them. We have two different kinds of cylinders and prisms. We have right and oblique. Right is what you've been dealing with the whole time. Oblique simply means that it's been pushed. So picture taking a square pyramid, it's the worst drawing ever, and pushing it sideways, you'd be left with an oblique. That top face, or this front one, is no longer rectangular, it's now slanted, but the base is still a square. It's not drawn to look like one, which is why it has to be labeled. Here, our formula remains the same, whether it's right, meaning it's standing up, or whether it's pushed sideways. Oblique and solids have the same formula. We need to find the area of the base. This is triangular. Triangular prism. So I need 1/2 base times height. The base of that triangle is 3, but I don't know the height of it. The 3, and I'm going to calculate its height. I did that on my calculator, and this is what it gave me. So I'm going to move that over here and call it volume equals 1/2 of 3 times height. It's the height of the solid. If you were to stand it up on its triangle, how high into the air is it going? 9. Grab your calculator, make sure in your calculator you're closing that parenthesis within that square root, and I ended up with 35.1 feet to the third. Volume of the oblique is the exact same formula. I get that it doesn't look square, but it's got to be drawn somehow. So the volume of the bottom is 7 times 7, which is 49. How tall is that shape? Height is always a perpendicular distance. It was drawn in for you here. Grab your calculator to the third power for units. Volume is generally easier. There are fewer calculations. Cylinder. Volume equals capital B times H, but remember here that capital B is a circle. Pi times r squared times h, so that's 25 times 10. I'm going to leave it in terms of pi so I don't have to pick up my calculator. Letter D, same thing. It's pushed over, but I still have, let's see, my radius is 4, pi times r squared, and it's 12 high. So I'm going to leave it as 192 pi centimeters to the third. Whoops, and I always do that because I'm used to area. So it's to the third. Spheres. Spheres is just a matter of plugging in the formula as well. 4/3 pi r, just be careful, it is to the third power. I kind of think volume, cubic, so here it's goofy. 4/3 times pi times 12 to the third. You could type it in and get a decimal. I'm going to show you how to leave it in terms of pi. I'm going to type 12 to the third power in my calculator. Then I'm going to multiply it by 4/3, and I'm going to use that ABC button. I ended up with 2,304 pi. If you want to type it all the way in, you'd have to just read a direction on a test or whatever. That's what I got when it was typed all the way in. Letter F. Letter F, you're trying to find R, and it looks a little bit goofy. They gave you surface area. So stop for a second, go back and think surface area. Surface area of a sphere is 4 pi r squared. So they gave me this humongous value, 4 pi r squared. That's multiplication, so I'm going to get the r by itself. You might be thinking, wait a second, are we supposed to be finding volume? Well, yeah, but first you need to find r. I typed that in my calculator and I got, let's see, r squared equals the square root of all of that. It was about, when I typed it in, it gave me like 84.99, kept going, whatever and whatever. I don't know if the directions are clear here, but if you look back on the previous page, it says find the volume of the figure, round the final answer to the nearest 10. You first need to find r. If volume is 4/3 pi r to the third, well, the reason why you did all this calculation is to figure out what your r is. I used that A and S feature on my calculator, typed everything straight out, and I ended up with volume. It was big, but it will be because the surface area was huge. 6 centimeters to the third. Let me know if you have a question on that one. You might, because it's a little bit weird. I needed to find r because it wasn't given. Composite figures. I know composite figures make many of you cringe. For volume, it is much easier. For volume, it is just as easy as adding the two shapes up. I'm going to add up the density and the thickness and the volume of this one, and I'm going to add it to that one. There's no subtracting out common pieces because we're not trying to just paint the figure. We're not trying to fill it with water and need it to be hollow. We just want to fill the red one up from the bottom to the top, and then fill the green one up from the bottom to the top, and know how many cubic feet of sand or concrete or whatever it was that you used. I take the same approach by drawing. I'm going to use this, and not to say that there aren't other ways, but I'm going to add up this tall one, which has a front of 4 here, a height of 8, so the 4 can also go down there, and it goes back 2. So if I'm going to talk about capital B, the area of the base is 8. It's 8 tall, so it's 64. On the small one, they give me the 3. The 6 was this whole length, and if that piece was 4, that one has to be 2. And then how far back does it go? The same depth as the other one, so that's a 2. So that bottom is 2 times 2, which is 4, times 3 is 12. Add it up. Similar for the other two. For letter B, we're dealing with half of a cylinder, and we're adding it to a prism. So that cylinder has a radius. The 17 goes all the way across. The 11's from here to here, so that piece has got to be 6. And then how far back does it go? it matches up in the prism, so I'm going to say that that back depth is, or that height is 12. 1/2 pi r squared h, 1/2 pi times 36 times 12, and I got 216 pi. Now I'm going to do the prism. I'm going to take the 11 and the 6, and it's 12 high. So that gave me 792. When I grab my calculator in order to get to tenths, I'm going to go ahead and type the pi in. So 216 pi plus 792 is 1470.2 inches to the third. Lastly, letter C is nearly identical to letter A. I'm going to pause my video. Why don't you go ahead and pause yours and see if you can get it. All right, take a peek at my final answer. Not to say there aren't other ways you can do the calculation and get it absolutely correct. I took the whole bottom, the 16 and the 12, up to the height of 5, found its volume, and then I added the little sliver on top. Other options could have been, let's see, how else can this figure be split? Other students might have found this part and then added it to this one and done this whole side one. Think about it going kind of all the way down and back. So 2 different rectangular prisms. Somebody else still might have found the entire shape, so the entire thing here, picture all of that, and then somebody might have subtracted out this top part that isn't there. So there are multiple ways to do these figures. I think you'll find that volume is easier. Just make sure that you stick with your formulas. Thank you, and let me know if you have any questions.